Yeah, but that was my screen, so it shouldn't be.
So we need to connect it.
Yeah. You have to connect this one. But it's HDMI, so probably you can still have another connector. Or if you try. Or if you would like this. No, it's working. Oh, should be. Oh, okay.
Okay, hi everybody. Welcome to the fourth day of the Literature and Computation Week at UCLouvain. Today we have two talks. The first one is a dual one coming from Slovenia, and the speakers were telling me that they have this number in their language, dual, not only singular and plural. Voila. We have a dual talk as well. It's a panel actually on the Embedia project. And the first speaker will be Senja Pollak. The title is Text Analysis Using Cross-Lingual Embeddings, Results from the Embedia Project. Senja Pollak is Senior Researcher at the Department of Knowledge Technologies, Jozef and Stefan Institute, Ljubljana. Her expertise is in natural language processing. She is the coordinator of the H2020 project Embedia, I just mentioned, co-lead of the project RobaCoffee, and participated in many EU projects. She's also involved in several national projects with the main focus on developing, besides the European Union ones, with the main focus on developing computation methods for applications in social sciences and the humanities. She has served on several conference organizing and program committees and published her work in numerous journals, including Computational Linguistics, Natural Language Engineering, Terminology, Language Resources and Evaluation. Without further ado, Senja, please join us. Welcome, Senja Pollak.
Screen.
Cool. Yeah, so hi, thanks for being here. I don't know is it okay? Yeah, so as Chris said, so I come from Slovenia, from the Jozef Stefan Institute, and so does Martin. And I will be talking about the Embedia project and more precisely about text analysis using cross-lingual embeddings. So, Jozef Stefan Institute is a large research institute in Slovenia, especially working in natural science and technology. The researchers are about 1,000 researchers. We come from the Department of Knowledge Technologies. We are about 50 researchers, and we are involved in many European projects and national projects. So, in this talk, I will present you some of the results of the Embedia project. So we were interested especially in cross-lingual embeddings. So there is recent trend in natural language processing with deep neural networks and building applications for monolingual but also cross-lingual settings. And in our project, we were especially interested in less represented European languages and in news media applications. So if you have the field of natural language processing, often you have a lot of benchmarks, a lot of tools that are available for dominant languages like English. And then when you have smaller languages, so Slovenia, it's like 2 million people, and you have other languages, so you have a lot of morphologically quite complex languages, and you don't have that much resources to build like the training data, and there are not yet available tools. So in our project, we tried to leverage the tools from dominant languages with quickly updating them to be ready for the use for less resourced languages. Another point is that when you have news media industry, again, you can have like big companies which invest a lot of money to have entire IT departments within the, I don't know, BC or Bloomberg. And when you have smaller companies, they don't have that developed tools. So again, we were trying to build tools that are usable. But there are also methods that can be applied to, let's say, digital humanities things. So I will give one example of how things can be used also for the field of digital humanities. So in terms of our project, it involved 10 partners. It lasted for 3 years. It finished like 2 weeks ago. So we came from 6 countries and worked together on all these challenges. So then the challenges, they were about comment moderation and comment analysis. For instance, if you have news analysis, you have this section of comments under the news, and there is a lot of hate speech and a lot of moderation has to be done. But you can also, let's say, detect the, I don't know, gender of speakers, try to understand the opinions, try to understand public opinions. Then in terms of news analysis, you can have very, let's say, non-innovative tasks, such as assigning keywords to the text, but this is the background for linking the articles, for searching the articles. So developing methods that you can automatically assign keywords was one of the priorities. But you have also sentiment detection, article linking, viewpoint detection applications. And in terms of news generation, we worked from very precise things, such as if you have, for instance, each day you publish how many COVID cases there were, and then you have to produce articles. And this kind of writing can be quite well automatized. On the other hand, we also work with more creative stuff, such as headline generation, where you need more creative approaches, but also less reliable. So I will just give a short background on word embeddings. So I don't know how familiar you are with the concept. Basically, as I said, a lot of our technology is using word embeddings. So if you have distributional semantics paradigm, which comes from much before the word embeddings, basically, if you know the context of the words, you can guess quite well what is the meaning of a word, right? So here is the example of the word Gribomont. So we have probably, we don't know what is it about, but if I say a bottle of Gribomont is on the table, everyone likes it, it will make you drunk, and we make the Gribomont out of corn, everyone would probably have quite a good guess that it's not a car or that it's not a computer, but probably it's some kind of beverage, and since it makes you drunk, it's an alcoholic beverage. So basically, behind the concept of word embeddings, that's it. So if you have the context, similar words appear in similar contexts. So if you have the word drunk, you would have the word wine, the word beer, and many other words that would appear in similar contexts. And on the table, again, defines many other words. So basically, this context is very important. So instead of looking just at the context, actual context of words, you can have the programs, how you learn word embeddings. So this representation, you use deep neural networks or architecture, and the computer will try to predict the word, but it's the same concept. So if you have a large amount of text, for instance, the entire Wikipedia and millions of books, and you would run it for 10% of words, such a program that it would try to guess a word and have probability for each word. Yesterday I ate a banana, so probably you ate it or you bought it, but you didn't, I don't know, calculate it. Right? Yeah, drive it. Yeah. And basically, then the embeddings are just vector representation of this, not really the context, but of these vectors that are representing words. So you would have vectors with similar meanings would be close together, like you ate a banana, you ate a mango, and they would be quite similar together in this vector space, but you did not usually eat a dog, and it would be a bit further apart. And the nice part with embeddings is it's also that it preserves relations between words. So the distance between man and woman in vector space is very similar to the distance between uncle and aunt, or king and queen. And this is the relation of gender, right? And there are like, the same is with capital cities and countries, or so basically in word embedding space you have semantics that it's somehow preserved. So you can have static embeddings where one word would correspond to one vector, but you have recently the most trendy things are called contextual embeddings. So basically in each sentence you would generate a different representation, and similar sentences would have similar representations. But for instance, we know that words are polysemous many times, so you have riverbank and you have financial bank, and these would be very different representations. So contextual embeddings, they allow for different representations of words with different meanings, and this can be either polysemous words, but also like words used in different contexts. So I will come to that later. So for instance, if you have, I don't know, more conservative media and more progressive media, these would be different contexts. And you can then use contextual embeddings to analyze these meanings. And for our project, it was very important, the recent developments in multilingual embeddings. So if you have not only that you train the models on like Google or Facebook, that not only do they train it on, let's say, Wikipedia in one language, but you have multilingual models, like multilingual BERT or Roberta and other models. And here we have some sentence embedding representations. So basically words that they appear in similar contexts. And you would have very close in vector space, even button and nice weather. So this means that you can then do transfer across languages. So the concept of transfer learning is that you first pre-train large language models on general corpora. So this is done by Google and by big companies usually. So you have this general knowledge already available in a monolingual or multilingual model, and then you fine-tune it on specific task. For instance, that you're working on a classification task, distinguishing between, if you're digital humanities, I don't know, author A to author B. You would have a lot of text by author A, a lot of text by author B. You would then fine-tune this general model on this specific corpora, get this knowledge of specific authors in, and when you would have an unknown text, the computer would be able to classify to A or B based on patterns that it saw. And as I said at the beginning, our main motivation was to work with this cross-lingual transfer. So if we have the models that have this joint embedding space, which is common across languages, it means also that you can train one model. So let's say the classification on one language. So if I give an example, let's say that you're making a difference between classicism and romanticism, the authors of one or the other period, and you have texts in French. So if you have a multilingual model, if you have sufficient amount of text in one language, you would suppose that with small amount of data in a new language, or even without any data in new language, you would be able to apply such a model directly. So this is like the nice part of this. Is if you don't have any text, it's called zero-shot learning. And I will now show a few examples of what we did in the project. People are waiting in the lobby, it says. That's interesting. It's okay? Yeah. So, we were mainly focused on news analysis because our media partners, so in the project there were 3 media partners from Finland, from Estonia, and from Croatia, so media companies, and we were developing tools especially for this context. So one of the things is main entity recognition. So if you have a text, in text you have locations, you have persons, you have organizations. And in news text, these are really the crucial elements of information. If you're linking the articles and you want to find similar articles, knowing that it talks about the same people, that's really crucial. So we were developing methods for recognizing these named entities and to categorizing them to different categories. So another application is keyword extraction. So here is the text about Luka Doncic, is a Slovenian basketball player. So, and when you have a news article, usually under the text, editors, they select keywords. They write keywords, what is this article about? And then when you search for articles or when you link the articles, you would use these keywords. So you can have unsupervised approaches. So this means that you don't have any training data for a computer. So here we developed a method using graph-based methods, and it's basically you would build a graph out of co-occurrence of words and then use some graph-based statistics to say which words are the most important. So this is quite nice, and it works for any, it's language independent, but it's not very reliable. So the best methods in machine learning nowadays are supervised. So it means that if you have certain amount of data, so we had articles that editors manually assigned keywords to them. We had this, but they would like to automatize this process, right? So in our case, we said, so how can we teach a computer to do this sequence labeling task to define which are the keywords in the text? So basically, if you have a sentence, here it has been another record year for renewable energy despite the COVID-19 pandemic. In the training data, renewable energy and COVID-19 were keywords. So this is just on sentence level. So you have an embedding representation. So basically these are just numbers. So this is like a vector representation. And with transformer architectures, you train an algorithm that would, for each word, it would say, oh, this is 0. So this is not a keyword, not a keyword, not a keyword. And then these two are keywords, right? And COVID-19 is keyword. And then you train the system. And in our case, we train it here separately for different languages, for Estonian, English, Latvian, Croatian, Slovenian, and it worked pretty well. So this is now implemented in a media house, and it's like an automated system from which journalists just confirm the keywords, or they add if our system was not completely correct there. But since we talked about cross-lingual transfer, so what the next approach that we did, and we're presenting it now at the conference, is if you don't have the data in a new language, you can just use existing data from other languages and apply it directly, because you have this multilingual representation. And here the results are a bit less good, but they are much better than unsupervised methods. So this is quite nice, right? So these BERT models are available for more than 100 languages, so it means that theoretically you can start using a system directly. So similar experiments were done with sentiment analysis. So here we published our work on zero-shot learning cross-lingual sentiment analysis. So we had here at the disposal one corpus in Slovenian that was labeled if a news article is positive, negative, or neutral, and only in Slovenian. But we wanted to have a method for other languages as well. Again, we use these multilingual representations. We trained the model by, so you have this three-class problem. You have the algorithm that transformer-based systems that tries to learn based on examples if it's a positive article, negative article, or neutral article. And then we analyzed it for the languages that were not seen at all in the training data. So again, this zero-shot learning setting, we call it. So in Slovenian, where we had 10,000 articles, the performance was 66%. But when we go to other languages, so Croatian, Estonian, Bosnian, Macedonian, Serbian, so some of them are the same language family, but let's say Estonian, it's not related at all. you can see that the performance drops like from 10% to here it's even a bit higher, which is strange. I mean, so we have very comparable results, and majority class it's like between around 20%. So it means that it's much better than random, and for sentiment analysis, which is quite, let's say, subjective and a lot of implicit meaning there, this is quite nice result. So basically it means that this cross-lingual transfer works quite well for many tasks. And similar for comment moderation. So as I said at the beginning, you have news articles and then you have this comment section. And when you talk with people in news industry, this is, I mean, this job is really depressing, right? You have people who are employed to read these toxic comments, and it seems that they get quite easily depressed and they change all the time. I mean, it's probably, this is a nightmare of a job, right? So this is really a task where they would like at least semi-automated systems, if not, I mean, automated has other problems as well if you block people without the reason. But here really helping these moderators, it's an important task. In some countries, you have even legislation by which you shouldn't post hate speech on your website, so it's even more important. So again, we treat it as a classification task. So it means that with machine learning, if you have a training data, the computer would learn the characteristics of different classes. In our case here, you have, let's say, blocked comment and unblocked comment from their previous blocking, what they work each day. We take this data and then we learn the classifier. So first we did it on their specific media partners data because they didn't have only blocked and unblocked, but they had also specific rules. So one is about hate speech, one is about insulting the moderators, one is about commercial content and so on. So we built specific moderation systems. But then again, we built also cross-lingual models because we want to offer the tools for other languages, not only for the specific media partners data. So here we had, these were public data sets. I mean, some were from our project, other were public. So these are very different languages, like Arabic, Croatian, German, English, and Slovenian. We again use these cross-lingual models, multilingual BERT, which is the one available for 100 languages. And within the project, we also had one trilingual one. And we again tried how much can this cross-lingual transfer work if you have offensive speech, which is even more, let's say, I mean, it is really non-standard language and so on. So here, the idea was that you compare, like if you have not any data available in your language, so this would be zero-shot learning setting, 0%, and then you add different amounts of data, and with 100% of training data, I mean, it means that you have enough data to train it yourself. And we compared these results. So here I will just show it for one language, but it's interesting. So if you look at this graph, so this would be Croatian data, right? And here at point 0, you would have no Croatian data at all, but you have English data available. And with only English data on which the model was trained, you can achieve relatively good performance. So it's like about 67% accuracy without any, without Croatian data being seen anytime during this fine-tuning phase, just in this pre-trained available model. And then if you go, let's say, to 30% of Croatian data and you add and you use English data as well, you can in fact achieve better performance than if you use 100% of English data. And this is quite nice. So it means that even if you're annotating, you can do much less annotation effort if you're training things for new tasks, if you have data available for other languages. So we also compared it to machine translation system because usually people would say, okay, but why wouldn't you just translate the data and then use it on that stuff? So if you don't have any data, the results are comparable, but this is faster and you don't need this machine translation step, which is nice. But if you have a bit more data, this approach is clearly outperforming the machine translation approach. And one of, another example. So it's also, as I said, so you have contextual embeddings, right? So contextual embeddings, they are the input for these algorithms that I showed, and they are more powerful because they consider context. They are not just words. They are, I mean, representation of words in context. But also, if you have corpus from different slices, right? Different corpora slices. So this is an example of the chronic analysis on COVID news articles. So you have January, February, March, and April. And then you have contextual embeddings, and you try to compare the representation in different months, in January, and February, and so on. And then we clustered the embeddings so clustering means like grouping the meaning, grouping the vectors together. So we produce several clusters. So here are the keywords representing each of these clusters. And then we compare the distribution across different months. And here you can see that in January and February, when we talk about COVID, it was really about new strains. So Wuhan, about new strains of coronavirus. And then in March and in April, you have this blue cluster and green cluster will become really dominant. And this is about economic strain, financial strain. We're talking about care systems and hospitals. So you can see how the discourse about, so this was for the word strain, so how strain is used in different contexts during different time periods. And I mean, in the project, we developed many other methods, including summarization system, article and headline generation, Twitter sentiment detection, fake news detection, and several other things. So when we discussed with Chris that I would present the NVIDIA project, I thought, okay, but it would be nice to show an example that this is also useful for digital humanities and for literature applications. So I got in touch with some researchers on literature and also with digital humanities. And we said, okay, let's apply this last method that I showed you on comparison of two different authors, right? So here you have Jozef, who is a Slovenian author. It was romantic realist, author of the first Slovenian novel and the first Slovenian tragedy. And we got a lot of his works. This is corpus, slice one. And then we have Ivan Cankar. So he was like the most important Slovenian novelist. He belongs to modernism and symbolism. He was in fact the founder of modernism in Slovenia. And we then use these context-dependent embeddings. So again, we built clusters, and then we looked which are the most changed words across two corpora. And for selection of these words, I will show you now these graphs and what were the interpretation. So this was for the word awake, zbuditi in Slovenia. So, and you can see that the cluster distribution, so this is Cankar, the modernist, this is Jurčić, so these are very different distributions of meaning, right? And then we have these descriptions, and we can see that in Cankar, there are the words like longing and the heart, and in that part we talk about nation and narrative. And the colleague from literature studies found this very, very interesting. So, in fact, when we have Josip Jurčić, the concept of nation is very important in his works. So this was the beginning of Slovene bourgeois narrative prose. And in 1848, when we have the springtime of the people, the concept of nation, so we were in Austro-Hungarian Empire, and the concept of nations was then becoming more and more important. And then the development of Slovenian nation and identity only raised at that time. So the first Jurčić novel is in 1966, so after the springtime of the people. So the awakening of nation is totally different meaning than awakening in terms of emotions, right? And then another word is this narrative. So this is also quite aligned with literature theory because the first literary programs were formed around this circle of Jurčić. And this is then also reflected in his work. On the other hand, you have this Sankar orange cluster. So the heart is, for instance, a symbol of emotions. It's about inner life. So it's a bit different concept of this awakening. Also here you have, for instance, the word answer. So we observed that in the most changed words, it was a lot about answering, saying, answering to someone. A lot of these words were the most changed words. And again, so we see here an example for the answer. So you have a cluster with Sankar about boys answered, why, hard, see, alone. And here you have answer to son, to husband, to girl, to brother. So in collaboration with Andrei Kajan, the interpretation was that in Sankar's work, the characters are not really speaking, but it's more this inner life of character that is discussed. They were like longing for speaking or this kind of expressions. And in Jurčić, it's really about dialogue of characters. So you have he answered to the son, he answered, husband answered. So this dialogue is reflected in this word. And you have a lot of relations between characters. So, and then was the word strain. So here it's really, the distribution is totally different. And here you would have words that in this cluster like face, to feel, time. So again, we have inner life, we have symbolism, and here we have to strain a rifle. So here you have Jurčić wrote the Seti Brak and Rokovnjači. You have a lot of epic scenes where conflicts between characters are explained. So this is just the same method that was developed, in fact, for news analysis applied to corpus comparison in literature studies. And now just to finish, so yeah, this was this is our website of the Embedia project, and here I would just like to show see if this works. So this is online demo of our tools, so that you see how it works. So this is like today's news on Russian and Ukraine, and I picked like article analyzer, so you can paste the text. And here we select, since the text is in English, we select our method, English sequence labeling approach, and let's say also named entity extractor. And then you run the system. Of course, in media houses, this is done not in the website, but behind, it's integrated to the system. But it shows like you can recognize the keywords like Russia, Lviv, and so on, and the keywords like Ukraine, Russia, National Railway, okay, CNN, it's a corpus artifact, but it describes quite well the article. And then if we want to have another article in French, so the system was never saw French except in this BERT pre-training. So it never saw keyword extraction task on French. But if we, so this is a Soir, so Belgian newspaper. So again, if you just try what comes out, if you don't have any, it never was trained for French keyword extraction, but we will use this multilingual model. And it was trained on Slovene and on English and on some other languages. And we can see if it makes any sense. So again, we can Ukraine, Russie, arme nucléaire, Vladimir Putin. So it works pretty well, given that it was not trained for that language. So this is a common analyzer, so this is always a bit unpleasant. So you must have like offensive speech to demonstrate that it works. And we chose several different models, and all of them find luckily this offensive, right? And then if we have like a nice, quelle belle journée, I should switch to French keyboard because I didn't get it. So, and we analyze this one, in that case only with multilingual model, because again, French was not within our languages, and we analyze it. So this is, okay, so it's not 100%, I mean, of course, you put on the demo the thing that works, but it's like the results would be much better than manual work, right? And just for the end, so Chris sent me some literary text. So this is a work from Victor Hugo. Here, the only thing that it's applicable would be this unsupervised system, because all the rest was trained on use for keyword extraction. So as I said, unsupervised systems are not that well, but still we could find some important words. So on, souris, regard, ast, attire. So it's still quite nice. So this would be like the important words from the literature example. And yeah, that's it from my side. So I hope you enjoyed it. And Martin will continue. Yeah, no, yeah, okay. Yeah, feel free
And
for any
maybe Martin
questions.
can start installing, I'm just saying, setting up.
Yes.
Okay, thank you so much, fantastic talk. For me personally, it was fantastic. Well, any questions or comments?
I just want to know how well does this work with late 18, 19 century
Sorry, can
What's
you-
that again?
Does this work well with late 18, 19 century texts?
18, 19 texts.
Yeah, 18,
Yeah.
19 texts.
I mean, so majority of the work was really developed for news texts, right? So our tasks like comment moderation, I mean, wouldn't be even applicable, I think. And for news articles, for instance, for keyword extraction, I mean, it was really trained on news. But this example that I showed,
That was 19th century.
yeah,
Brilliant.
oh, yeah, I mean, we had only last few years of news archives. But if you have, I mean, the nice part of this supervised system is that, for instance, if you had the training data from older periods, it would work. And this example that I showed on this Jurčić and Sankar example, or diachronic analysis. So this is typically the thing. So you have a pre-trained model which is mainly using contemporary text. But then if you fine-tune this model on 18th and 19th century data, it would get this knowledge, right? So it would adapt to that period. And then you could, of course, analyze either more similar words in the embedding space, or even compare it with the usage nowadays. So you would have, for instance, corpora slice of 18th century, corpora slice of now, and you could compare how the meaning of words changed or anything else. But it would need this, probably it would need this fine-tuning phase where you just run it. So you were not here in the beginning, but basically in fine-tuning, you give it to your corpus, you would mask some words and it would somehow adapt to your text. Yeah.
So even the models that you train them on bird and fine-tune them for you.
Exactly, yeah. So basically this, this cross-lingual analysis, it would be applying BERT. I mean, then we use mainly multilingual BERT, but when we work with the languages, with Slovenian and so on, we also built like another version of BERT, more fine-tuned on that languages. I'm sure it's possible to have training on large historical corpora, which is probably nice, but yeah, I think it works quite well.
Thank you.
Thank you. Any other questions? Yes, Isabelle.
First, thanks so much. I mean, I'm really super duper impressed by the project. It's super cool, and all the different applications, like from literature to like modernity comments. I mean, it's really amazing. I have a bit of a question that maybe it's a bit naive, but I was wondering if you were, let's say, interested in doing some like semantic, distribution semantics with some specific multi-word expressions or maybe entities that you already know, like, and you could fine-tune with some body of text where these are already merged together.
Mm-hmm.
I guess that would work with BERT, right? Since it works across different languages, I guess, even if it doesn't know the specific entities and multi-word expression, it would still.
Yes, sure. I mean, all these models. So in BERT, for instance, so in these contextual embeddings, which is now like the predominant paradigm. So basically, you have byte per encoding representation. So this means that even for so words that are in the vocabulary when you train the model, you would have, you would have the words. And then for words that are unknown, you would split the words to like common character substrings, to put it in a simple way. So basically, even if there is like a new derived adjective from a noun, it would still understand that it's a similar word. It would have this root part, which is similar to the meaning, and then it would have this adjective information. So basically, all these models, they deal quite well with out-of-vocabulary words. Then in terms of multi-word expressions, it's a bit different. So either you have a system that specifically treats multi-word expressions for a specific task, or otherwise you can compose the meaning. So for instance, if you have just two words and you had like average of these two words, usually it's not ideal, but you can still deal with them in that way. On the other hand, yeah, for recognizing named entities, you would train it on multi-word expressions, and then you recognize multi-word expression. That's not a problem. I mean, that's the purpose. So basically, it's a sequence labeling task, and these models, like BERT architecture, then are very good in recognizing sequences. So if in your case you would want to recognize, I don't know, named entities or idioms or any kind of multi-word expressions, you usually need the training data, and then you make this task specific. And this for any kind of multi-word expressions, this works quite well. But then it depends. I mean, we also worked a bit with metaphors and with idioms, and of course some tasks are simpler. I mean, named entities are simpler than metaphors, for instance. But it's still, I mean, it works quite well.
Okay, thank you so much.
Yes, thank you. Thank you. Okay, any other question? Maybe a pragmatic one. So is this available?
Yeah, so everything is available. So basically some things are integrated by media companies, but we are really on the open source side of community. So GitHub code is available for everything mainly. It's on our website, and there are many tools. And so all these corpus slices, I mean, all this is free GitHub code.
Fantastic.
So then we have these demos that you can use. Right. And we have even some Docker containers which can be integrated. So it just depends on the license type. But yeah, if it's used for like programming, I mean, you can just take it and fork it and use it.
Fantastic. That's fantastic news.
Yeah.
Great.
I mean, even if you need some help, let's say for this diachronic analysis, if you would like to use it, we can make some specific session.
Okay, that's very generous. Good to know. Thank you. You guys actually did one that I attended like a month or two ago, right? When you presented, and you were like so welcoming that attendees can come with their own data, and you.
Yeah. So this is what Martin will show. So this is like an example of something that's really available for, let's say, non-programmer users, but it's also he will show more. No, it supports, let's say, less complex stuff because it's used online. But if you are able to at least run the code, I think going through this GitHub, you can even then adapt it and add like named entities modules, or I mean, you can make it more specific to your needs.
Fantastic. Okay. Another deep learning component. Where does it kick in?
I mean, all this is deep learning, right? So basically, when you have the BERT models are trained with deep neural networks.
You're talking about the models being deep learning.
I mean, yeah, everything here, all this sequence labeling. I mean, the models, it says the representations are deep learning. Then all these architectures used here, all these transformer architectures. So this sequence labeling, I mean, it's really, and classification tasks, all this works nowadays the best with these transformer architectures, deep learning architectures.
Okay. Well, any other questions? Yes?
I was just wondering if anyone on Teams had questions. Please feel free to unmute yourself and ask away or write it in the chat.
Yes, and then for until now, like for instance, for fast text that I've been using myself, and boards, of course, fast text, like you have to like transfer, right? Maybe like a translation of vectors. Did you?
Yeah, I mean,
do that as well?
so this is, but
we're anticipating a little bit, right?
Yeah, so I mean, so he will show some fast text examples. So the difference is that in fast text, these are static embedding, right? So one words have one vector. So it's very, it's easy to analyze like what is the closest word, you know which is the word, you know what are the closest words. In word, you have, I mean, it's embedding in the context. So you have then to average across all the, let's say, occurrences or a sample of occurrences and so on. But since it's a multilingual model, so basically you can do this cross-lingual transfer without specific alignment. But
right, which you have to in fast text, right?
I mean, in textbooks you have to align them because I mean it's multilingual, so you can use it separately for all the languages. But if you want to do any kind of multilingual analysis with fast text, you have to do the alignment. I mean, here it's very simple because you have, but it has. I mean, here you would have these pre-trained models and you would fine-tune them. In fast text, the nice part is that you can train it from scratch quite easily, and it's of course much less complex. I mean. Yeah, it really depends on your needs. No?
Right. Yeah. Okay. Good. Any other questions?
And you don't need that. I mean, these are some GPU intensive stuff if you're
programming. Yeah.
So it also depends on.
Yeah, because the text that the data that I passed along, I use fast text on it.
Yeah,
like
and it would
English
work.
and French works very well.
Yeah, and it would work fine with smaller data sets.
Exactly. Yeah.
So here, like, yeah, it all depends a bit on the exact use case.
Yeah. But indeed, computing resources don't have to be big and, fiddling with fast.
I mean, I think if you have any supervised systems, so not just analyzing, but if you are learning stuff, so this BERT architecture, it's really, I mean, this is really quite powerful. I mean, here you gain a lot with this transfer learning, which, the performance is better, with these models, but it has other.
Well, trade-offs.
Yeah.
Right. Yes. Okay. Any other questions or comments? Well, if not, a big round of applause. We'll move on to the next section of this dual presentation. This panel on media. The title is Natural Language Processing Online with Cloud Flows, right? And our speaker is, please correct me if I mispronounce your name, Martin Schnidarsic. Perfect. Good. Also from the Jozef Stefan Institute. Martin is a senior researcher at the Department of Knowledge Technologies of Jozef Stefan Institute. His main research interests are in data mining, with a focus on evaluating modeling, text analytics, and computational creativity. Applications of his work are conducted mostly in the fields of ecology and finance. Well, it's a good profile to have at a literature and computation event. So we're very lucky to have Martin here. Please, without further ado, Martin, you have the floor.
Thank you.
Thank you.
Thank you for the introduction and for amazing pronunciation of my surname. So yeah, my name is Martin and I'll present Cloudflows, which is an interesting piece of software that we are developing at our institute. Recently it got really quite a few natural language processing components thanks to NVIDIA project, so it might be also interesting for you. Now, Cloudflows is a visual data mining platform, and it's not the first one out there, of course. So there are others like Orange, RapidMiner, Nime, and some others. So these platforms are really well developed and established, and they are very similar to one another. So here we have a screenshot of Orange. So typically in these platforms, most of the screen for the user is the canvas part, so this white part where you actually have place to put the software components, and then you can connect them, and this is called visual programming in a way that you put the software components there and then you just connect them with the mouse. Now, typically you also have somewhere in the screen on the left, typically this collection of software components, the so-called widgets, which you move onto the canvas and then connect. Now, depending on the platform, I mean, it can be visual programming just by connecting the inputs of one the outputs of certain components as inputs to another, but you also can have forking, you also can have some loops, depending on the platform. So it's a visual programming which allows some simple programming input-output and sometimes also some looping tasks. Now, Cloudflows is also such a platform, but it is different because it is entirely built online. So it works in browsers, so there is no need for any client-side installation on your machine, and all the execution is being done on the server side. So it has some good points in that you do not have to install anything, so you can be any user with any kind of privileges. You only have to log in into the platform. So it's much like the Google Calendar or something like that, just not so well developed, of course. And this server-side execution also means that you do not have to have the latest and greatest machinery to run some more computationally intensive things in Cloudflows. But the main point of Cloudflows was to ease the sharing of work, actually. So as it is an online platform, it is much easier for us, of course, to allow very easy sharing of one's work. So if you develop a workflow, you can easily share it with others so that they get a copy and they can replicate your work. If this is an experiment, they can run it, they can rerun it, they can see, does it really run? If I repeat it, do I get the same results? Can I change the parameters? What happens then? I mean, does it only work with this specific set of parameters? If I change a few decimals, is it crappy then, and so on. So this is this typical academic replication of experiments which we were after. And the other thing is that they can also build upon. So what they get is a copy of a workflow. It's not the actual workflow which is yours. So they can easily change these things without harming your work in any way. And they can extend it. They can say, okay, what if I add something more? What if I change some components? So that's the whole point and the whole idea behind it. But at the end of the day, it's a research prototype. So yeah, it's not a software product as such. So some things are buggy, especially the recent ones. Sometimes it doesn't work, and so on. So sometimes you get frustrated because some documentation is not perfect. So yeah, research prototype things. Now, it was developed, I mean, it's being developed for more than 10 years now, and the main developer was, and still to some extent, is Janez Kranz. And I would just like to spend a minute maybe on versions, not to cause confusion, because the first version was this Cloudflows 1, the original one, which was active for most of this time. This was used, as I said, for experimental replicability, but also for one of the focuses was software integration. So we were trying to use this in collaborative projects where you have different teams, and each team is focusing on a specific component, and sometimes it's really then difficult to integrate them together. So we were using Cloudflows to somehow loosely connect these components, integrate them, demonstrate how they work, and then share with others so that they can see, okay, see, this is how they work together, and maybe use it in this way or some other way. And so it was a bit specific focus, and that version also had over the years a few forks, like text flows was the fork which was specific for text mining, and concrete flows, for instance, was one which was focused on computational creativity. This was very project-specific one. So the one which is active now is Cloudflows 3, and this is one which is now being developed. We call it Cloudflows 3 because there was a second generation in the meantime, but yeah, this was, let's say, a dead alley that we went to. We wanted to improve on Cloudflows 1 in some aspects. These ones, for instance, to store intermediate results and so on, to allow more users to use it at the same time. But yeah, we tried it one way, it wasn't okay, and now we tried it another, and I think this is a good way to go. So when you are using, now you should use Cloudflows 3, and I'll give you a URL in a second. So it has some new functionalities compared to previously, and especially some new NLP components. Also now the main developer is Vid Podpechan, who has a much better fitting bio, but he couldn't be with us here today. So, so I'm presenting this work. And now just a few moments on the open source part of Cloudflows. So if you are a normal user, you would just go to this URL, CF3, because it's Cloudflows 3, so CF3 IGSSI, and you just register there and start using it as a user. But if you would like to use it in a way that you would host your own version of Cloudflows, this is also possible because it's open source. So the entire code, the whole server-side machinery, the entire front end and back end, everything is under a very permissive license. So you can just simply download everything from the GitHub. Here's the link to various components which you need. And then you can just set up this infrastructure maybe in your institution, and then you can host and run the server on your site. And then it will be a different URL, but it will be a different, let's say, instance of Cloudflows, maybe for internal purposes or something similar. Now I'll go to a demo, but just before that, let me just show a few screenshots because we won't have time afterwards. So this is the main window of Cloudflows. Here is the button you should press first if you decide to try it. So try the tutorial. This is an interactive tutorial which drives you through the use of Cloudflows, let's say through a typical use very slowly and easily. Otherwise, users would typically press the new workflow to start working on a new workflow, or to explore existing workflows. This brings you to a list of workflows which were made public by others. Yeah? Because, Cloudflows, this W here is not a typo. Actually, it's not only cloud and workflows, it was also crowdsourcing, which was one of the words which we wanted to have in the name. So these are some things to have in mind. And also, the login, first when you try to use it, it will ask you to log in, or first to register, just very basic things, mostly just for updates. And this is then the canvas that you are greeted with. It would be empty when you start, but typically it looks like this, as other platforms. Canvas, here are the widgets, they are like in such hierarchy that you can search through them, but typically you use this search here on the top. And here you put them on and then run and play with the workflow. So there are a few things here, a few buttons to let's say open and store. This is one which is interesting to save, of course. This just gives it a name, and then a button to play. So to run the entire workflow, so all the things which can be executed to be executed from left to right. However, in Cloudflows, you can also run individual forks. So for instance, in this case, if I would only be interested in this result, I would not run the entire workflow maybe, because why waste time? I would just go to this widget and say, okay, run only this widget, and then this would cause only the widgets which are on its critical path to be executed. So this is how you sometimes spare some time. Now to the sharing part. Of course, also in this respect, Cloudflows is not the first thing available. There are workflow sharing platforms specifically for sharing workflows. Like my experiment platform is one such a thing which existed for many years. Now, in the field of machine learning specifically, we have this OpenML initiative, and they have also many interesting workflows there. There might be some from natural language processing as well. And they have this metadata for easier searching and finding similar things, so it's really nice. Well, Cloudflows doesn't have some of those functionalities, but it offers to execute and construct on the fly, so this is also something nice. It takes care of all these things then to run it on the server and parallelize. But yeah, maybe something which I did not mention previously. We also have some issues, of course, because of this online operation. Let's say data transfers can be really lengthy. If you have a few gigabytes of corpora and you have a bad connection, it will take a long time that it gets to Cloudflows. Also, very big data sets do not travel well through the certain widgets. But sharing is really easy if you have a workflow of your own. So when you would click the Your Workflows button, you would get all the workflows that you have developed. And then if you would like to share a specific one, you just go here to this button, make, this is a public one, but if you have a private one, just click Make Public. And in this case, you will get here a URL, and you can save this, you can attach this URL to the domain. This is then the URL of a workflow, which you can send to somebody, and they can click on it and get their own copy. Yeah. So when you do this, when you make something public, it also automatically gets represented in this list of publicly shared workflows, which is available here by clicking here. And in this case, here all the publicly available workflows. Let's say this one on the top is not from me, so I can share the link and I can have a copy for me. But this one, which was made public by me, I can also edit it. Yeah? So this would be editing directly the live version. Of course, I cannot edit this one because it was by somebody else. I cannot ruin his work, of course. Now, a glance through a few of the widgets that are available. So what you would expect typically, input loading, some things with tokenizing text, various tokenizers, for instance, and lemmatization. We have only one widget for lemmatization, but it's a really good one, and it supports many languages, including French. Here's just an example of how it works. And it works really properly. Also, is goes to be, and so on, as it should. And then the interesting ones, maybe for today's context, are the ones with embeddings. So we have the typical pre-trained embedding models. So all the ones that you have heard previously. So we have the bird animal, glove, and all these things trained on huge corpora. Also, we have some of these versions trained on these specific languages which are less represented. This might be less interesting for you, but yeah, you have also this general purpose one or general language ones. And then we have also some classifiers based on these models. So these are also available for hate speech, for sentiment classification. This is all available also in Cloudflows if you would like to play around. But much more interesting is maybe this one, which is the one which we offer also in a way that we can learn the embeddings online. So this is the train fast text. So it's the fast text algorithm for embeddings. And in this case, we can train this on our own corpora. So we use this train fast text widget to get the model, and then we have a few widgets which we can use together with this widget to get some interesting things. For instance, in the demo, I will show you how we can check for the neighboring words of a word once we learn such a model. And of course, yeah, we have also some embedded specific widgets for these tools that Senja was showing you previously. But these are just the wrappers for the web services. So the web services which exist, they were shown on that web page, and here in Cloudflows we only have a wrapper which calls that service. So it's completely the same. Now let's go to the demo. Oh yeah, so I have to open anyway. So here I'll go to Cloudflows, I'll log in. Let's say that I will start a new workflow. And as we said, I would like to train fast text. Okay, we put a widget here. And then as input, we would need some text. So I think that load file to string would be the good one. So this will allow me to load a file to Cloudflows. I choose a file. I will pick Moby Dick. This is just a Moby Dick novel. Okay, and now if I would check this, for instance, with some preview, let's say object viewer is such a general purpose viewer of anything in Cloudflows. So I can just connect them together. I click with the right click here to get the menu, and I say, okay, run and interact. So I will run only this, and I get the novel Moby Dick. Yeah? So here are the chapters, and well, that's it. It's just text of Moby Dick. Now this train fast text widget needs not text but list of strings. So it needs to be a list. Okay, this is a trick. And I need to create a list out of this. So I will put this string into this widget, create list, and this list could go here into that widget. So this create list is quite useful in some cases when you would like to add, I don't know, maybe not one novel, but maybe 10. You can just add them like this and they will appear, you know, these inputs will appear as you add them. You can add as many as you like. And also, yeah, if you would add more, maybe it's a good practice to rename this to something else. I already have it here prepared. As you can see, when I was preparing to give this demo, I already did that. So this is Moby Dick now. So this could go here into train fast text, but it works even better if we use a tokenizer, let's say in between. So let's put a simple regex tokenizer, which will also take care that everything is in lowercase. Now, okay, and then we train the fast text, and then we will check for neighbors. So fast text neighboring words. The result is the model, and I have here the model, which goes into this neighboring words. Okay, and here I have to present also a list of, well, things that I would like to have neighbors for. So again, I need to have a list of strings. Like this. And let's say whale would be an obvious choice. Okay. And I can just use this object here. Like this. So now if I run this thing, I should get all the neighbors of the word whale if I train the embeddings model only on the Moby Dick novel. So it should be very Moby Dick specific. Well, one single novel is really not a big corpus, so the results will not be perfect. But we can see that we get something whale, whaler. These are very similar things, very probably because of some settings that we have here, and we should change. Yeah, okay. So we should go to a few settings now. So one set of settings is here in the train fast text widget. So for those who know how this algorithm works, they can make use of these parameters. For those who don't know, and this is typically the target audience of Cloudflows, so people who don't know programming, don't know the algorithms in details, you have some hints. Increase or decrease these defaults for small data. One novel is small data, so we can, let's say, decrease this a bit, increase this, let's say, to something like that, learning rate, double that, dimension, decrease, okay, let's say 40. Okay, so this is one thing. And here in these neighbors, we also have two parameters. The first one is threshold, and this is filtering based on how closely similar the word is by characters. So if we leave 1, it will not filter at all. If we put this threshold at, let's say, at least 0.9, then it will remove those neighbors which are almost the same words. Yeah, so just variations. And the other parameter is how many neighbors would we like to see. Let's see 10 rather than 5 while we're at it. So now it should be a bit better already. Are we running out of time? No? So we see now it's a bit better. So whale, sperm, because it's a sperm whale, this is a species of the whale which Moby Dick was. is which of the, we have a lot of stop words actually here, so this is not really nice. But we can get rid of those too. So we could also check previously if stop words are a problem. So we can check the frequency, let's say, token frequency. Okay, we take the tokens here. I'll put another object viewer. Let's see the frequency of tokens. Yeah, the, of, and, only stop words, whale is here, well, somewhere down below. So yeah, it would be really cool if we would get rid of those. And we can. So we can simply put a token filter in between and say, okay, let's filter the tokens, and then we'll check the frequency. But for filtering, by default, it only filters out strange characters and numbers if they're appearing there, and some HTML things. So not very useful for stop words. So we would need to enter our stop words here. Yeah? So we have to, let's say, Google up English stop words, and there are nice people out there who are sharing those, and you can simply copy them. You enter them here, and that's it. And now if I check what remains after the filter, it's much better. So we see whale, one, upon, ship, Ahab, and so on, captain. Yeah, this is more useful, it seems. So now it should be about okay. We can also, well, to push it even further, we could add also a lemmatizer in between. So let's say that we also lemmatize this a bit, just to show how the lemmatizer works. So tokens go here, and the lemmatizer also needs language. So if you go to help, you would see the languages it supports. Also French is here. I don't know for Dutch actually, it might be missing. Well, but English is what we need here in this case. Yeah, I think the Dutch is not supported. So English, and this needs to be entered as a string. So create string again. And we enter that we would like to have English lemmatization. And then this goes into the train fast text. So the train fast text now will get what? It will get a tokenized Moby Dick with filtered out stop words, lemmatized, and it will work with those parameters that we have set. So yeah, we have to put some effort into this anyway, you know, so it might be not so hard, but you have to try a bit and see what is the problem and try it out. And now we have something useful. Yeah? So whale, the first result is the entry word, and then we have the most similar ones semantically. Okay, sperm, I already explained, this is sperm whale species, and then we have Leviathan, which is like a big thing, whale with some things, baleen, and so also some things which do not seem to have semantic connection. Probably they do not have it, but yeah, these are vector embeddings. Not everything is perfect, and especially if you learn on small corpora, you can expect some strange things. Yeah, yeah, you could include it in the stop word list, but yeah. This is how you play around with this and see what you get. But yeah, okay, whale is maybe a very specific thing. So if you would like to compare this with another novel, let's say with Dracula, then you should use something else. I tried, believe me, I tried whale with Dracula and get nothing, of course. And let's say we use blood, of course. Yeah? Okay, so we'll run this with blood. And we get something. Blood, bloody, and other things. Okay. I will now copy this to clipboard to store it for later, because I would not like to lose it, so that we'll be able to compare. And now let's load here Dracula, another novel, which will be instead of this one. Okay. And in case of Dracula, okay, blood will be again okay. Yeah, that's it. We'll just rerun it. That's it. And now let's see what we get for Dracula. Yeah, so a bit different, of course. Oops, sorry. Ah. So you have bloody beaten vein here, suck, poison, and so on, wound. So yeah, this is more Dracula related. So this is context which is more related to blood in Dracula than in Moby Dick. So yeah, this is maybe one way how you would use this to compare things and to compare what is the context of words in different things. Now, what I would like to show here before finishing is also how we store this. So this is now an untitled workflow. And if you do many untitled workflows, you will just get a list of untitled ones in your workflow list. This is really annoying. So this is why you push this button, save workflow, and you give it a name. Yeah. So let's say that this is literature and computation week demo. Okay, I can make it public right now, but I won't, so that I will show you how it's done later on. So now it has a nice name, and if I go to my workflows, it should appear there. So yeah, it's at the end, so page 17 in my case. So here, literature and computation week demo, and I can edit. Yeah, if I click edit, I get to this workflow. Yeah. But I can click, yeah, also to delete it or something else, but I can also make it public. So if I click this, now it's public. So now it's available to anybody. So here is the URL. I can copy this link, send it in an email to a friend, and this is now the public URL to this workflow. Yeah? And anybody with this URL can go to it and see what's in there, get its own copy. You have to be careful with making this public, because also the data is then public, of course. So if you're using copyrighted data, well, don't. Now it also appears among these workflows, which are being public. So currently there are not so many, just 4 pages of them, because this version 3 is quite fresh. But here it is now. So it says, okay, it has this name, it's by this user, it was uploaded. And I can here share the link, I can launch the copy, and since it's mine, I can edit it as well. And that's it. So what I also wanted to show, but there's no time, so I would just maybe show you just a screenshot. Can I show a screenshot? I have an entire video, if I would have any problems with connections, of a very of a workflow which is typical for machine learning use of these embeddings. Actually, of how embeddings are used typically, as Senja was showing, but it's a bit lengthier. So yeah, as you can see, we are quite happy. We can skip this. It has a lot of content. The input there is a data set which is shown here, which is data set of 10,000 news items. So these are Slovenian news with sentiment also prescribed. Yeah? And the catch is how to learn a model that can then classify sentiment. Now in Cloudflows, we can play around with various embeddings, and this is how you would use Cloudflows to play around with effects of different embeddings algorithms. So here we're just entering this data set. Okay, we are using the tokenizer, and here we are using various pre-learned, pre-trained embedding models. So here are now these 10,000 news items, and when they enter this, they will get as output here 10,000 vector representations, okay, of each of those. And here with this fasttext algorithm, again, 10,000 different ones. And with, I don't know, fasttext Isabelle, 10,000 different ones. And I could run each one of them separately and see, okay, which one is better for classification. Or I can use these concatenate embeddings and concatenate all of them. So why not use all the possible vectors? I mean, vectors are just features, and you can just add more and more features. Yeah? So I can also use them all together. Yeah? And then I can see how do they perform. And then there's a bunch of widgets which are just to prepare the data set, because it's a bit annoying to prepare a machine learning data set from textual data. So I have to take the embeddings, I have to take the labels separately, and then prepare here a data set which is prepared in a way that we can run machine learning models on. And then, yeah, we split the data sets to train and test. In this case, we apply support vector machine model, which is a bit last decade top used models, and we can apply this to the testing data set and get some classification statistics. So performance, in this case, F1 measure. And what I'm showing below is that here this F1 measure is, I don't know, 0.65 or something. But we could also go another route. And this is that we would use, as with Moby Dick, yeah, we could use a custom built trained fasttext model on this data. Yeah? So, of course, this is not a huge corpus, I mean, 10,000 news items, but it would do something. And then we get a model, but we have to use this applied trained model to get the actual machinery for getting the embeddings out of data. So that actually this pair of widgets is something similar to one single widget here. And then again, the same thing, the same story, and we get a result which is, well, a bit worse, but not much. Yeah. So this is how, yeah, you could use also this approach and see how do they compare. Is it better to use? So you can use Cloudflows to play around and see, I mean, to experiment and see, okay, is it better to train, even though it's a small corpora, to train on small corpora and classify with these embeddings, or is it better to take Google's BERT and that embedding space for this task? It depends on the task, perhaps. Yeah, and this is why, well, this is how embeddings are typically used. That's it from me, I would say. Thanks.
Thank you. Thanks a million, Martin. Questions? Comments? From the chat?
Thank you for the presentation. What type of tasks can you also sentiment analysis or other specific tasks using this framework?
I mean, you could use, I mean, any machine learning task in this way. So if you try to copy a bit this workflow, it's also public. You can find it. So it's embeddings evaluation, and you can use it for such a task. But yeah, if you use it really for big data, then Cloudflows will not be a good solution. So it depends what you have. So if you would like to build a classifier, then use it on small data, and if this, let's say, if the classification method is not too demanding, it could work. So anything that you need for machine learning, if you can represent it as a machine learning problem, you can use that, because it has all those data mining tools inside. It was initially a data mining, I mean, it still is a data mining and machine learning platform. I was just showing today only those parts which are dealing with text. There are not many, but at least there are some, and I have shown those. But anything, I mean, if you have sentiment as the target, you do sentiment classification. If you have, was this written, I mean, also you can have totally numeric data, of course. So is this patient, I don't know, going to recover or not, then you are classifying that. And any task which you can represent as a machine learning task. Yeah.
Thank you.
Thank you. Any other questions?
in the context of, let's say, text classification and any target that you have. But you need to have a target. You cannot. Sometimes people we would like to use machine learning because we don't know the answers to something. Yeah, but it has to learn on something. So yeah, it's sometimes not so easy to
I mean, let's do apply a model that was trained, right?
Yeah.
So if you have a model that someone else trained, like you need to use Sentinel, then you take your model as a pre-trained model, and then you can apply it. So
yeah, those pre-trained, but there are only a few. You have we have sentiment, but multilingual sentiment and hate speech detection, and I don't know. Yeah. So if you do not have data, then only hate speech and sentiment would be. Only those are as pre-trained models. Yeah.
If not, you need to train, right?
Yeah.
You need to train yourself.
Sorry?
If not, you need to train yourself.
If not, you need to train yourself, and then you need to have data with labels. Yeah.
Right. Okay. Yes? I have a question. Why fast text this time around?
Fast text because it's fast enough to work in a reasonable time, because most of these embeddings methods take a lot of time. Let's say it's not unusual to take, I don't know, 2 weeks, to train if you have a right purpose. And this fast text, I mean, others would take hours sometimes, and this is really easiest to use. Also for us, it was quite easy to implement in CloudFlows, and it's really fast, and it's quite useful. So it's an improvement over Word2Vec, also as a method. So it's let's say a good choice.
And we're talking multilingual fast text embedded, right?
No.
The basic one.
This is the basic fast text embedding
257, whatever languages that they cover, right? You're talking about those monolingual ones. They're like 200. Yeah.
Yeah, but this fast text, it can learn on anything. Yeah.
But it can learn, yes. It can definitely.
So its fast text works in a way that it takes tokens, and then for each token, it does all the substrings, and then actually builds embeddings for each substring, doesn't it? And then it combines them together in such a way.
I mean, here, so what I think shows the one, for instance, you have this pre-trained fast text model set, and then here you can build your own ones.
Right.
And then, for instance, in the video, we also build the higher quality corpora for, let's say, our languages. And then you can compare the performance, right? If you use different embedding models, but yeah, what been said for very great stuff. I mean, if you put one novel to Word.
Yeah.
So there you always have this pre-trained model and you Python. So the fast text is the best one. I think it's not trained from scratch. And this was like so if you use pre-trained models, there are many out there. So I think one of the things people would like to play with is building from scratch, or to show like a long Dracula or.
Yeah. I mean, we might support also others in the future, but then we will have to put a warning. So you can run it, but log in again next week. Because it's the server is quite it has quite a strong machinery behind, so it can run so fast also because of that. But still, with those bugs, this could be easily days.
Those are huge. Yeah. Okay. Any other questions? Yes.
Yeah, this is the third version, and it's up and running and being used by the researchers. And I was wondering, where are you heading with this? What are your wishes for the fourth version or other installments?
Yeah, currently we are just trying to make. So in the recent year, there are so many developments because of Embedia and so many new features being added. Some of them needed to be added really quick because of the needs of the project, for instance. Also, it was quite lively, so many new methods were added and so on. So now we would like to take some time to just, let's say, consolidate a bit, to clean it up. When you do these fast additions, then some things stop working and so on. So for sure, now it will be a time to just stop adding new things and just consolidate, and then we'll see how it goes on. With CloudFlows as a platform, We also were quite unsure some time ago how to develop it further because it's becoming serious in a way that we cannot support this as researchers, you know. So then you have this whole software maintenance issues and so on, which actually you would need a company to cover this. And we are thinking that maybe we would create a spin-off and, you know, just hire a few developers which are full-time on this, and it's their problem, and we can still use it, let's say, for free, or we can have a public deployment for demonstration. So we are not sure about that, but certainly regarding development, it will be a consolidation now for this year, for instance. Yeah.
And an additional question related. So this demonstration that you gave was really insightful. Does the website also include like a tutorial and help function? If you're
Yeah, so
Yeah, it's there.
it does have a tutorial. So if you go to the main, yeah, so here is this, try the tutorial, but this is this interactive tutorial, yeah? So this is it. So we can try it. So try the tutorial. Now it's, oh, hello, welcome. Go to the first step. And now, okay, this is the widget repository. Click a widget, put it on the canvas. So you see, this is this interactive tutorial. But we do not have a written one, and we do not have good enough documentation, so to say. So it's annoying in this respect that every widget also has. Okay, let's put the widget here. Every widget has a help here. Yeah. So every widget has a bit of an explanation. And this is as far as we have it, you know. So each widget has this help, and that's more or less it. We are working on adding documentation which would be better. So currently it's only this interactive tutorial like that. What is annoying is that sometimes you do not know what is input to some specific widgets. Yeah. Like I had this with lists of strings. Yeah. So this is very practical to have lists of strings because you can just put them together and you have more results, and this goes through the whole pipeline. But it's a bit annoying for new users because it's unintuitive. Why would I have a list? And if it's not written anywhere explicitly, you do not have a warning. You know, in these well-established platforms like in Orange, in RapidMiner, if you do a wrong connection and you run it, you get a warning. This is probably not connected in the right way, and so on. Of course, yeah, these are years of development. On their side, we do not have such things. So this is sometimes it's a bit frustrating for the users. So yeah, if you do play with Cloudflows and running such problems, just send us an email, and we'll try to help that way.
Very sweet for you guys. Okay, yeah, well, then, you know, like make a quick joke. If you have a background in Python, where you do everything with lists and vocabularies, like, of course.
Of course, lists. What else would you use? Yeah.
Okay. Further questions? Comments? If not, thank you so much.
Thank you very much.